Hey guys, welcome back to the channel. This will be part one of a new series I'm starting where we will answer the question, can ChatGPT help us design a set of 3D printed ITBs for my budget 5.3 LS engine build? This engine will be going into my budget Rat Rod Roadster, and since it will be a street car, we will use ChatGPT to help us design a set of ITBs that will best suit our application. And if you're new here, please consider subscribing, it's free. And also get caught up on my build by checking out the playlist in the description. So let's get started. After discussing what I was planning to do, ChatGPT wanted to know my engine specifications. Things like displacement, compression ratio, horsepower goals, and where I wanted peak horsepower to be in the RPM range. They responded with a few options in throttle body diameter coupled with the application for each size range. And since this will be a street car, I decided to go with 47mm throttle bodies. And then it proceeded to show me a bunch of math as to why that size would work best for my application. Feel free to pause to read the explanation. And now we get into runner length. So this would be from the valve seat all the way up to the lip on the bell mouth. Chat suggested that we should be in the 330 to 380mm range. And that would put our peak horsepower somewhere between 4,000 to 5,000 RPM. And before we get started with the actual design in CAD, I just want to show you some inspiration I have. This is just an old issue of Hot Rod Deluxe. And I just love the way this car looks. This one's called the Bare Metal Brawler. And look at that intake. It's just really cool. And yeah, this is a Hemi, but I really want that look for my Rat Rod project, so that's where I'm going to start, and that is my inspiration. The computer program I'll be using is Onshape, and it's a browser-based program, and it's free to hobbyists. A lot of people will use Fusion 360, which I have used in the past also, but I've just been using this recently, no particular reason other than the fact that it's been working well for me. Now, before I get started, just one thing I want to note is that this is not an instructional video on how to use CAD. Most of my CAD experience was way back in high school with AutoCAD, and it was not this type of design. It was mostly just designing houses and stuff like that. And I had to learn this program just through YouTube videos, and they have really good instructions on the website. So if you want to get started with CAD, I just suggest you just do it. Go on the website, make an account, and just start designing things. Take measurements, invest in these tools, and just play around. And it's not difficult, and the programs are simple. And the videos that are on YouTube and even on the site that show you how to do certain things are very helpful. Here's a sketch I found using a Google search, and it gives me all of the important dimensions that will help us get started designing our intake manifold. Everything else from here will be a combination of ChatGPT and my own imagination. So the first thing I've done is I simply put in the dimensions from the drawing into the CAD program. But the next thing I gotta do is, we can see here that this is flat. But if you look at the LS intake, we have an angle there. Simply just gonna take my angle finder, put it on the flat of the table, about 35 degrees. Looks like we're closer to 34 degrees. So we're just gonna start from there. After making a wedge at the 34 degrees, I began establishing the base of the intake manifold that would mount to the surface of the cylinder head. I want this intake to work with off-the-shelf parts, so I'll be using this Felpro gasket, and I'll also use these ARP intake bolts that work with GM Performance intake manifolds. And finally, after a long day sick at home, I finished designing the intake runners based off the specifications from ChatGPT. In a later video, we will be designing the throttle bodies themselves, but for now, let's send this over to the slicer and begin printing. So this is the 3D printer I purchased. I've had it about a year. This is a Creality CR-M4. And the reason I bought this is because the print bed is big enough so that I could print this intake manifold all in one piece. And this one is for a K24. I printed this for my K24A2 engine that will be going into my Civic project. Now, you can print with a smaller printer, which is what I did here, and I simply hot glued it together. And this is great for prototyping, but if you do want to make a functional piece, it probably would be better to print in a solid piece just so you don't have any failure points. But these are just some prototypes printed in PLA. And then right now on the printer, I just printed a hub-centric ring for some wheels that I'm trying to fit on my Rat Rod project. I think I paid about $900 for this printer, which is a great deal. It's a great printer. There are some negative things that people say, but I simply think it's because they just don't know what they're doing. There are some printers out there that are a little bit more plug and play, but I've had no major issues with this printer and it's great. So if you need a large format printer to use, this is definitely a good one to start with. Before I start my prints, I always like to clean the bed with 91% isopropyl alcohol and a clean microfiber cloth. This will remove any dust or other contaminants from the bed that will prevent the print from adhering properly. Finally, I adjust the Z-axis using this piece of paper as a feeler gauge, and we are ready to print. Well, that's all we have time for in this video. Next time, we'll see how the print turned out, make any necessary adjustments, and then we'll move on to designing the rest of this ITB intake using our specifications from ChatGPT. If you liked this video, please give it a thumbs up and leave a comment. And if you're looking forward to the rest of this series, consider subscribing to my channel. Thanks again for watching, and I'll see you guys in the next one.